Atlantis Stretched Cluster. Just a few housekeeping items for everyone before we start. This webinar is being recorded and we will share the playback with you following the event. If you have questions throughout the webinar, please ask them in the questions tab of your webinar panel. Also, the slides are in the handout section if you'd like to download them. With that, I'd like to introduce our two speakers today, PD Prasad, Senior Director of Product Management, and Jerome Knoll, Senior Director of Partner and Customer Marketing. PD.
Thank you, Natalie. Hello, everyone. This is Priyadarshi. Thank you for joining the webinar today. Within the next hour, we are hoping to cover our latest and greatest Atlantis Stretched Cluster solution, a solution that we believe can provide our customers a really high availability solution without the associated high cost of a traditional DR solution. Before we get into the stretched cluster solution itself, let's just take a brief look at Atlantis product portfolio. For some of you, this may not be any new information. What you see on the left-hand side is Atlantis USX, which is our software-defined storage solution that delivers a new generation of storage for enterprise and small and medium business customers. As an SDS solution, what Atlantis USX does is it pools and abstracts any of your existing or new storage devices through our patented technologies such as hyper-dedupe data reduction technologies. It delivers then massive amounts of storage savings. Not only that, with a nice write avoidance strategy, it also delivers massive improvements in performance. And then on the right-hand side, you see Atlantis HYPERSCALE. HYPERSCALE brings the benefits of USX architecture in a pre-packaged, easy to consume and use compute plus storage appliance format. As you can see, what we expect to see at a customer site is when this appliance arrives at a customer that they are able to start doing IOs and running their applications within about 20 minutes. So really, really quick time to value. Atlantis HYPERSCALE is also the only flash optimized hyperconverged appliance in the industry that brings the performance of flash, obviously, the enterprise data services of the USX architecture, but all of this at a cost that is lower than that of traditional disk-based storage. How we do that is essentially a lot about the architecture itself. So if I were to just give you a 2-minute overview of the architecture, USX is able to virtualize, pool, and abstract any physical storage hardware that may be thrown at it. And that helps even for Atlantis HYPERSCALE as well, because of this capability, we are able to support HYPERSCALE right now with 4 different hardware vendors, namely Supermicro, HP, Lenovo, and Cisco. Once we have pooled and abstracted everything, our deduplication file system brings inline deduplication and for certain volume types, compression, delivering unmatched storage efficiency. Not only that, as I mentioned briefly before, our inline deduplication follows a write avoidance strategy, which then results in massive performance acceleration. And then we present that storage as either an NFS share or as iSCSI share. Once we have done the data reduction and the performance acceleration, we overlay our enterprise data services on top of that, and this is where things such as snapshots, replication, and now stretched clusters actually become relevant. The entire solution is extremely resilient. We can easily handle obviously any component level failures such as drives going down or volumes going down or nodes going down, and now obviously with stretched cluster even complete sites going down. We also have some unique features such as VM teleport option, where you can migrate a VM, a virtual machine, from one vCenter cluster to another vCenter cluster, and that migration is deduplication aware, i.e. we only, in that process of migration, we only send unique blocks of data. And then finally, all of this enterprise data services and the inline deduplication advantage that we have and the pooled and abstracted hardware can all be managed using a very simple UI, and then on top of that we also have a very comprehensive RESTful API interface. So that's in 2 minutes the overview of the architecture that brings storage efficiency, performance, and enterprise data services to our customers. We have been working hard to deliver features and capabilities at within a very short time. As you can see, just within a year, we have delivered massive amounts of capabilities, the latest one being with USX 3.1 that brings stretched cluster and also 3-site disaster recovery solution, which I will also touch upon today. But getting into stretched cluster, I am happy to report that with one of our early access customers, Shared Service Center Zwolle, a customer based out of Netherlands, we actually won the Best of VMworld award at VMworld Barcelona. Just a little bit about the solution that we configured. SSC Zwolle, we're looking at a storage infrastructure of somewhere around 420 terabytes to achieve a highly available solution with a traditional storage system. And that obviously was prohibitively expensive, and it was also consuming a lot of data center space, power, and cooling. Stretched cluster and using vSphere as the hypervisor, we were able to bring the storage requirements down from 420 terabytes to about 120 terabytes, resulting thereof about 60% flat storage efficiency and cost savings. There's a nice case study. I have provided the link, and as Natalie mentioned below, the entire slide set is available for you. You can download, and feel free to go to that link to get more details about the SSC Zwolle solution that won Best of VMworld. So how is it that we are able to reduce the cost of achieving high availability by as much as 50 to 60%? Well, traditionally, if we look at high availability, people can traditionally either achieve very high availability, which is represented here on the x-axis by terms such as recovery point objective, which represents amount of data loss that you may see if there was a disaster, and RTO, recovery time objective, which represents the amount of time that one would take to bring their applications up and online after a disaster has struck. If you, as a customer, are comfortable with high RPO and high RTO, let's say an RPO in hours and an RTO of 60 minutes or so, the cost of the HA solution can be actually very cheap and simple. People can do at a very basic level just snapshots. They can then put those snapshots on backup devices and then ship those devices to a different site. Could be fairly inexpensive. However, what you lose there is should there be a disaster, you are only able to recover from that previous backup. And it would take a lot of time to bring all of those tapes back into your data center. However, if you now go towards the zero RPO and zero RTO goal, the cost of solution becomes prohibitively expensive, and at least in traditional architectures. At Atlantis, we offer solutions across this entire spectrum, as hopefully you can see on the slide here. For local HA solutions, we offer snapshots, both volume level and with VMware vVol integration at a VM level snapshot as well. For far size, we offer volume replication, which is an asynchronous replication that you can use to protect your data across literally thousands and thousands of miles and kilometers. However, with volume replication, obviously, the RPO is not going to be zero. The minimum RPO we support with volume replication right now is 60 minutes. With Stretched Cluster, at metropolitan distances, you can achieve a solution that delivers zero RPO, so absolutely no loss of data even when your entire site goes down, and then zero RTO, so no loss of IOs, basically every single IO that and across two data centers that are there at metropolitan distances. From an application standpoint, that spanned CVs or number of hosts appear as belonging to a single cluster, single host cluster. And typically, metropolitan distances of about 100 miles, about 150 and 60 kilometers are supported in this configuration. The key requirement, obviously, there being that every single I/O that happens and goes to the storage device needs to get replicated in a synchronous fashion to the other data center. And so that kind of limits the distances that can be there between the two sites, because if the distances are obviously too large, then for every single I/O you would have a lot of latency. At Atlantis, what we did is we looked at the traditional and typical stretched cluster solutions, and then we said, what can we do better? So what I'm representing here now is the Atlantis stretched cluster solution. And you can see here we have site 1 and site 2. These are your production sites. Both sites can be production. You can have applications and VMs running on both the sites. And what you see over here is a minimum of 6 hosts, or 6 nodes, stretched across 2 sites, 3 on each side. That is the minimum number of nodes that we require for a stretched cluster solution to provide high availability, not only at a site level, but also within a site level. And then on top of that, you see Atlantis USX. So essentially, USX, when deployed in a stretched cluster mode, considers nodes across both the sites as essentially local nodes to itself. And then it distributes and stripes its IOs and consumes resources across all the 6 nodes as if they're all local nodes. So those are the 2 sites, site 1 and site 2. We also have a tiebreaker at a different site. It doesn't have to be an entire data center. It just needs a place where you can run a simple virtual machine, and that virtual machine essentially acts as a tiebreaker should you lose connection between your site 1 and site 2, between your production sites. And the requirements for that tiebreaker are fairly simple and straightforward. It just requires about 4 gig of RAM, 4 gig of actual disk space. If you can just do it 10 provision, it's just from a network standpoint, doesn't really require high bandwidth at all. All you need is enough bandwidth to send some heartbeat information. Consequently, the round-trip latency times are fairly flexible and easy for that tiebreaker, as you can see, about 200 milliseconds or below. So that's the tiebreaker. Between the 2 sites themselves, though, the maximum round-trip latency we support is 8 milliseconds or lower, which, of course, to my previous point, the greater the round-trip latency, the higher the response time would be for IOs that need to travel across both sites. The network requirements are 10 gig or more, and obviously we recommend that you have resilient networks, so redundant networks across both the sites and also between site 1 and site 3, and then site 2 and site 3 across the tiebreaker. So that's the simple schematic of Atlantis Stretched Cluster solution. Some additional details are captured on the site on this slide over here. I covered most of it. I think some of the interesting thing is the entire stretched cluster solution can be done using just local storage. So using storage within your servers, within your blades is fine. At present, we do not support the stretched cluster solution using shared storage. So if you have traditional, say, EMC NetApp or whatever, we would not support such clusters using that storage, but you can always put storage or drives in your hosts or nodes, and then you can configure a stretched cluster solution over there. Now, that's the basic principle of stretched cluster. Now, how we are able to save massive amounts of storage and also bandwidth with Atlantis Stretched Cluster is because of one fundamental architectural reason, and that is our stretched cluster implementation is below the USX deduplication file system, which means that for every I/O that comes to us, if it is a duplicate I/O, then we only need to send the metadata over to the other site, which is hugely beneficial from 2 important standpoints. One, of course, because you have USX on both the sides, you are automatically saving whatever inline deduplication savings you're getting. So it could be 50, 60, 80 to 90%, depending on the workload. But then secondly, for every duplicate I/O, I only send the metadata, which means 2 things. The bandwidth requirements on the links that connect the 2 sites are actually quite minimal. I'm only sending the metadata. We have measured that the bandwidth requirement could be lower by as much as 50% or even more in some cases. So that's number one. And that goes directly to the, if you're paying someone like an AT&T or Verizon for your network links, then we can directly cut your monthly bill of using Stretched Cluster by half or more. So that's number one. Number two, because for duplicate writes, we only send the metadata, the updates that happen on the other site are much quicker, obviously. And so we don't have to, or if there was a duplicate write, before we acknowledge the host that the write has been committed, in traditional solutions, that write has to be committed on the local array, then it has to travel, and then it has to be committed on the remote array, and then the acknowledgement comes, and then we acknowledge the host. Well, it is much quicker to simply send the metadata and then update that metadata on the far side. And that happens much quicker. So the deduplicating file system not only benefits, the first benefit, of course, is it lowers storage requirements on both sides. The second benefit is we are sending less data over the network traffic. And the third benefit, of course, is from a performance standpoint, it's quicker to update the metadata. So quite, using some of these features, we are essentially able to bring the storage cost down and also keep the performance intact. Unique writes, if we have unique writes, then obviously we update the data and the metadata and send it over to the far side as well, because this is a high availability solution, and we absolutely need to ensure that every single piece of unique data is available on both sides at all the time. So that's one piece of it. The other piece of it where USX Stretched Cluster solution is actually quite unique is that every single volume in USX forms an HA solution with its HA volume that's always deployed on the other site, and then with the tiebreaker individually. So in this example, volume A and volume AHA on two different sites and the tiebreaker, those three form a quorum. Similarly for volume B and volume C. So every volume forms, it is its own HA solution, and they form a quorum with the tiebreaker individually. How that helps is, should there be a case where just a single volume were to go down, we don't have to fail over the entire site or the other volumes that are still up and running. We just fail over that specific volume, which is good because, failover, even though it is automatic and transparent, obviously always has some overhead. Your applications will pause for a few seconds, 30 seconds to 60 seconds. So there's always that overhead. And so if I'm only able to granularly fail over specific volumes as the need may be, it is good for the application. So let's get into some failure scenarios and how we handle each one of them. So let's start with the obvious one. It's kind of like covered. If one of the volumes fails, well, the tiebreaker will detect that, and then it will just bring volume AHA in this example up on the other side. And that's about it. Once that volume AHA comes up, applications can keep doing IOs. The important point to understand is this failover happens typically within the timeout period of the application, which if you're running applications on vSphere or Zen Server, and by the way, Atlantis Stretched Cluster is supported on both vSphere and on Zen Server. So if you're running applications on those two hypervisors, typically the timeout period is anywhere between 120 seconds to 180 seconds. And our failover happens typically within that timeout period. In our testing, we have seen as low as failover happening within 22 seconds. And it can go up, it can be higher than 22, obviously, depending on how much data you have on the volume that we are trying to fail over and all that. So that's the straightforward handling volume failure scenario. If we were to have an encounter scenario where one of the nodes were to fail, then there are several possibilities, and all of this happens automatically on its own. So I'm just describing it for sake of knowledge. But assume that on that node, there it will find that storage is always available. If there was a USX volume service that was running on that node, on that failed node, then obviously the tiebreaker will detect that. It will detect that the volume service has gone down, and it will automatically and transparently fail over and restart the HA service of that volume on the other site. So that's the node failure scenarios. Now in a three-site solution, even with redundant links, there are chances that at some point in time, some of the links may fail. So let's look at all the link failure scenarios. Let's say the link between site 1 and site 2 fails, and this is the classic split brain scenario where the two sites don't know what's happening on the other side. And typically, traditional solutions that do not have a tiebreaker, they basically shoot an arrow in the dark, and they have some policy maybe predefined and say, if I lose connection to the other side, just always bring site 1 up or always bring site 2 up, or basically they're just flipping a coin at that point in time. However, with a tiebreaker solution that we have, we are able to detect that even though the link is down, the sites are up and running, both the sites are up and running, and the tiebreaker is able to communicate to both sites or all the volumes on those sites. And so a link failure between two sites, the split brain, is actually of no impact at all, because we are just able to run and keep running all the volumes as business as usual in this case. In this example, in this scenario, one of the sites have lost connection to the tiebreaker. Still, there is no failover required because site 1 and site 2 are connected here, and site 2 and the tiebreaker is connected. So everything is available, no failover happens. In this example, the tiebreaker is completely isolated. It has lost connection to both the sides. Even in this scenario, there is no failover required, and no failover happens because both the sides know that they are connected to each other, and the volumes know that they are able to talk to their HA service, and there is no downtime. So this is really important because by introducing a tiebreaker, the last thing that you want is to in some way reduce the availability of your solution, and we don't do that. If the volumes are able to communicate to their HA volumes, then they just keep working. And so that's really, really important and interesting. Now let's look at a scenario where one of the sites gets completely isolated. In this example, site 1 is completely isolated. So now site 1 detects that it has lost quorum. It can't communicate with the tiebreaker. Neither can it communicate with the other site. In this scenario, site 1, all the active volumes on site 1 will come down, and all the HA volumes on site 2 will automatically come up. And then once they come up, basically it's a failover that's happening. Then they'll just keep serving IOs to the application VMs, regardless of where those application VMs are, by the way. Because the application VMs, as far as they're concerned, they're accessing a common storage. And so whether site 1 volume A is up or site 2 volume A HA is up, it doesn't really matter to them. There is no requirement for changing none addresses, for example, as in traditional storage, nothing. It's volume A HA comes up as volume A and just keeps doing IOs for application VMs that may be running on either of the sites. If the entire site, this is the true disaster scenario for which typically customers look at solutions like Stretched Cluster. If the entire site goes down, then obviously we detect that on the storage side, and we just fail over and bring all the HA volumes on site 2 up and running. And then we expect the hypervisor to kick in their HA and then bring all the VMs that they had online on nodes that are there on site 2. And once those VMs come up, they will see storage is available, and they'll start doing IOs there. So that's the straightforward scenario, obviously. This is what the solution is designed for. There's a scenario where all 3 links go down at the same time, complete isolation of every site. Now, before I go into what happens over here, it's important to remember that this is an extremely unlikely scenario, because the scenario really is that all three links are down at the exact same time. Consider the case where the links are not going down at the exact same time, but it's more like a rolling failover, which is a more practical scenario where site 1 first loses connection to site 2, and then after a certain period of time, site 1 loses connection to the tiebreaker, and then after a certain period of time, the tiebreaker loses connection to site 3. So typical practical scenarios are failovers are always rolling over in nature. In that scenario, there would be enough time. All we need to do a failover is about 10 seconds to detect that one of the sites, one of the volumes, is not connected to the tiebreaker or is not connected to the other site. That's all we need, 10 seconds in that rolling failover scenario. And if that happens, then that would give us enough time to basically just start the failover on one of the sites and then keep applications running on that other site, on that second site. However, let's come back to the scenario where at the exact same instant or within 10 seconds, all links go down. In this scenario, no site knows what's going on the other site, and so what we do programmatically is we put both sites down, we freeze them, and then we expect the administrator to come, look at what is the environment, and then bring one site up. So that's what we do. Now, it is important to note that every time we do a failover, there's always a question of what happens when I'm able to restore the other site. So if volume A went down and volume AHA came up, or site 1 went down and site 2 came up, eventually after a certain period in time, customers will be able to restore service on site 1 that has failed. What happens then? Traditional solutions, what they do is, after the point in time when the failover has happened, after that point in time, all writes that have happened on the other side, they will need to send all those writes to the first site to make sure that there's a proper resync and all that happening. So if you imagine a scenario where site 1 failed, site 2 came up, and then 4 hours later, site 1 comes up, all write IOs that happened within that 4-hour period will need to be sent over to site 1 to be in a resync, to be in a sync state. With Atlantis Stretched Cluster, through our dedupe file system, we are actually able to do a little bit more things a little bit more intelligently. If we detect that one of the sites has failed or one of the volumes has failed, then on the other volume, we maintain a bitmap of all the changes, and those bitmaps are dedupe aware. So within that 4-hour period, let's say, if 80% of writes are duplicate, then when the time comes to resync, we only send the metadata and the unique block of writes. In other words, we'll send the 20% of the writes that were unique and the metadata for the rest 80%. So the resync operation can be really, really fast with Atlantis Stretched Cluster solution. Okay, now with the Stretched Cluster solution, as I said, this is a metro cluster solution. The solution works really well at metro distances. But there are obviously customers who would like to have a stretched cluster solution coupled with a far site where, as part of their 3-site DR strategy. And we're happy to report that this functionality is also available and supported with USX 3.1, where customers can do a stretched cluster, picking a geographical example, let's say between New York and New Jersey, and then they can also have their remote data center either in San Francisco or Houston or wherever, and then for that remote replication every hour, and that's the minimum RPO for remote replication an hour, but depending on your bandwidth that you have available, depending on the rate of change of data, you may want to go with an hour or 2 or 3 or 4 hours, whatever your link can support really. But nevertheless, if there is a scenario where a disaster strikes an entire metro area, so it impacts both New York and New Jersey, for example, then customers using this solution can bring their applications online at that third site, obviously after some loss of data, because RPO is not going to be zero at those distances. But this solution is available, and this is like the pinnacle of HANDR solutions, and that is available in the industry. And in the hyperconverged and software-defined storage segments, I'm not aware of any of the solution that does this three-side DR solution yet. So what we also did is we compared our solution with the available stretched cluster solutions in the industry, both on the traditional side, Meta being an example of a traditional solution, and on the software-defined hyperconverged side, Mechanics and vSAN being those examples. And what we see is not only, at least we consider our solution to be more resilient, because we support three-side solutions with Tiebreaker, enabling a predictable failover, failback, and also granular failover, failback. Don't fail over if you don't have to. Also, the round-trip latency is a little bit more, relaxed at 8 milliseconds. Deduplicating file system, and not just deduplicating, but inline deduplicating file system enables us to reduce network bandwidth requirements and enables us to improve write performance. The resync after failover is fast, as I described earlier. The granularity is at a volume level, which is nice, and the licensing is all-inclusive. So existing USX customers do not need any level, any tier of license or SKU to get this capability that's available to them, which is different typically from other solutions. So that was pretty much the end of the stretched cluster piece of the webinar. Now let me hand over to my colleague Jerome to talk about other interesting things. Jerome?
Yeah, thanks, PD. So just a few minutes, we at Atlantis are running a series of events for our HYPERSCALE appliances. So if you have an interest in hyperconverged appliances, our HYPERSCALE appliance family is a family of all-flash hyperconverged appliances, and we're getting fantastic traction in the market with these. The more benchmarking results we do at customers against competitive systems, we're handily outperforming them. And of course, even with our all-flash architecture, we're coming in at price points 50 to 80% less than the competitors. So again, this is getting phenomenal traction in the market. There's a number of these events that are coming up. There's some in the UK. There's one coming up in New Jersey, and you can register to attend these. It's a quick series of presentations for partners, which takes care of your certification needs, and for prospects, it's a 30-minute presentation followed by some really fun kart racing. So I don't know if you've ever been to one of these indoor karting places, but it's a ton of fun. And the best news is if you win the race, then we send you on an all-expense-paid trip to Las Vegas, which we call the Atlantis Cup. And there you get the opportunity to drive very high-performance cars, such as those that you see here, on a racing outing. So it's definitely something that you would want to attend if you like cars or like racing. I mean, this is kind of the ultimate experience. So, if you're in the neighborhood, definitely stop by and attend one of these karting events. You can find more information on our website, so please go to Atlantis.com and you'll see the links there to register. So one other thing I'd like to ask is we have been nominated for the TechTarget Impact Awards, and we are one of a short list of products that is up for winning this category for hyperconverged. So I'd like to ask you all to visit this link here and vote for HYPERSCALE. I mean, this is a phenomenal offering, and love your support in terms of us winning this prestigious award. So you can see the link there, and I encourage you to go and vote for us. Also, there's a whole host of new materials if you've not seen them on our website. If you're interested in reference architectures, we have a number of new reference architectures for Zen Server as well as for VMware Horizon View, as well as other third-party analyst results in addition to Microsoft SQL. And then there's also a cost comparison tool on the external website as well. So if you've ever wondered about Atlantis HYPERSCALE, the product that I was essentially just speaking about, how that competes with other competitive offerings in the market, take 5 minutes, take a quick look, and I think you'll be really impressed with the differences in cost. And again, remember, this is an all-flash appliance. There's absolutely no rotating media in use at all, and they are wicked fast and 50 to 80% less than competitive offerings. If you're an Atlantis partner, all of this is available on the Atlantis partner portal. So simply log on there and you have access to all of this. So with that, I'd like to open it up for questions. And PD and I are here, happy to take your questions and give you some, answer all your information that you'd like to get. So PD, you want to answer the first question there?
Yes, we have quite a few, indeed. So the first question is it possible to have Metro Cluster and also snapshot replication together, or make snapshots what I have on both sides together? Is it also possible in this mode to have snapshot VM, or this is per volume? Okay, so there are two questions there. The first one, is it possible to have, when you have a stretched cluster solution, can I take snapshots on both the sides for the volumes that are active on both the sides? The answer is yes. Can I then do replication to a far side, i.e. stretched cluster volume is also being replicated to a far side? The answer is yes, that's the three-side DR solution. And then the third question, do I snapshot the volume or the virtual machine, the VM? The natively, Atlantis supports both volume and VM level snapshots. The volume level snapshot is essentially just go to a volume and just do a create snapshot or schedule a snapshot. The VM level snapshot will leverage VMware vVol integration. So it is available only with vSphere, where with VMware vVol integration, if you take snapshots of the VM from vCenter, that snapshot activity gets offloaded to Atlantis, to USX or to HYPERSCALE, and then we do the snapshotting operation at our end. So that's how it's available at the VM level. The next question is Site 3 just a VM? What's the requirement? Yes, Site 3 is essentially just a simple virtual machine. And we actually provide the OVF, the executable for that VM. If you can just download it as part of your USX download. Requirements from network and bandwidth standpoint are very low, and we do describe the requirements in much more greater detail in our online documentation. But at a high level, just a few gig of thin provision storage, 200 milliseconds of round trip time with each of those two production sites. So that's very large distances and very low bandwidth requirements. They essentially are just sending heartbeat things there. The next question: what do I need on the third site for DR? Do I need also USX license, or is that included? Great question on the licensing. So for the third site where you're running the Tiebreaker, you don't need any USX license. There's no storage you're managing there, so you don't need any USX license. However, if you're talking about the three-side DR scenario that I described, where you have a Metro Cluster solution between two near sites, and you have a far side where you're replicating using USX replication, then there you do have a volume, and there you do require a license to bring that USX volume online, or to play with that USX volume. For Metro Cluster, can we not use attached or shared storage? Not yet, not in this release. Right now, our stretched cluster is only for hyperconverged storage. That shouldn't mean hyperconverged volume type, for those of you who know USX. It just means that it works with local storage. You can have hyperconverged volume type, you can have hybrid volume type, you don't care as long as the storage is local. And if you think about it, there's a good reason why we cannot support, at least just right off the bat, a shared storage-based stretched cluster solution, because if you're using NetApp, then we'll have to rely on NetApp to also fail over should there be a failure of the data center. And you can't make that assumption that NetApp metro cluster is also configured. You may have NetApp on one side and EMC on the other side, and then of course you cannot fail over at all. And so by keeping it local to the nodes, we have complete control over every resource, and we know that when we fail over that, our resource on the other side will be available. The next question is, what type of performance overhead does the USX volume incur with replication turned on? Great question. So we guide, obviously the correct answer is it depends, obviously, but we guide customers to have, to over-provision around 20% more in IOPS if you were to turn on replication. That's a high number. That's a conservative high number. Our ASAs and ACs will look at your environment, and when you set up, it also depends on the rate of change, obviously, and then how much deduplication we are able to do. If we are able to do a lot of deduplication and the rate of change of data is not that much, then the overhead is going to be very, very low. On the other side, if you throw encrypted data, I'm just making it extreme, obviously, but if you throw encrypted data where the rate of deduplication is going to be very low, and if the rate of change of that data is very high, then the replication overhead would be higher, obviously. How many total metro sites can we include in a cluster? How many total remote sites can be included? So in a single cluster, you can have, it works across 2 sites. A single cluster works across 2 sites, okay? Now, that doesn't mean that if you have 5 sites that you cannot configure stretched cluster across those 5 sites in pairs. So you can do 5C2, so 10 stretched cluster implementations across those 5 sites. You can, if you only have 2 sites, you can also do multiple stretched cluster configurations. So let's say you have 2 sites and you have 64 hosts on one side and 64 hosts on another side. What we would recommend is you do a stretched cluster configuration with 16 nodes, 16 hosts, and then you have basically 4 stretched cluster configurations that are independent, but they all can be managed using the same AMC. So there's a lot of flexibility there. Is the metro cluster to third site replication working also on Zen server? Yes, because that replication feature is essentially native to USX. We don't care what the hypervisor is. Is stretched cluster available in HYPERSCALE appliance? Not today, but we are working on it. And if you've seen our history, we first bring features on USX, and then after that, after a short period of time, we bring that feature on HYPERSCALE as well. So we are actively working on bringing stretched cluster on HYPERSCALE appliance. Can only hyperconverged volumes use metro cluster configuration, or is it possible with simple hybrid volume too? So the answer to the first part is no. Not only hyperconverged, you can also have hybrid volumes that can use stretched cluster configuration. The answer to the second question, can simple hybrid volumes use? No, you can, because simple hybrid obviously by very definition means that you only have one host that is contributing to that volume. So there's no HA, there is no stretched cluster. But I think your question was more around, can hybrid volumes use? Can I create a hybrid volume across 6 nodes? Yes, you can, and you can put them in stretched cluster mode. So I think that covered all of the questions that are at least here. If there are more questions, please contact us, and we'll get back to you on that.
Just one other question, PD. How is this priced?
Stretched Cluster on USX is included in the basic USX license. It's just free, available for free for anyone who has a USX license.
Great. So if partners have prospects out there that have been looking for a very high performance but yet very cost-effective DR or HA strategy, sounds like a really good fit.
Yeah, that's how it goes. That's what we intended to do. All right.
Well, again, yeah, the presentation is listed in the handouts of the webinar menu. So if you'd like to download that, please do. And anything else, PD?
No. Thank you so much for your time.
All right. Thanks, everyone.